Hey, 171 class, this is your first section of notes, section 1.2, the basics of functions in the graph. So what we're going to start off with is what these things are, functions. And to get there, we have to go through this thing called a relation. So a relation is just any set of ordered pairs. So just grouping two things together. So relating one thing with another, basically. And the set of all the first components in the ordered pairs, which we typically think of as the x's, is called the domain of the relation. And the set of all the second components, which we typically call the y's, is called the range of the relation. So to find the domain and range of a relation, so I'm given this relation, set of ordered pairs. This thing right here and here at the ends are called set brackets. And that lets us know we're dealing with a set of objects. And when we see those around a group of ordered pairs with commas between them, ordered pairs, think of those like as points, if you're familiar with an XY point. These are points, and a collection of them in set brackets is called a relation. Okay, so all the set of all the x's, these first things in each one of these points, is the domain. So when I'm told to find the domain of a set of ordered pairs or a relation, I'm just listing the x components in a set. So 0, 10, 20, 30, and 40. Alright, and then when I'm finding the range, that's the set, the y components, or the what we call the dependent variables. So I just list all the y components in this thing. Alright, and then there are the y components. And if you look again, it's the set of all, right? The set of all the first components, the set of all the second components. So we put those in set brackets as well. Alright, now the difference between a relation and a function is a function is a specific type of relation. So a function is a relation in which the things from the first set, the domain, every element from the domain corresponds to only one element from the range. So each element from the domain, right, the first components, corresponds to only one element from the range. Now, if you're looking at this first relation, you may be looking at this 6 being repeated here. And you may be thinking, well, that doesn't fit the definition. Well, it actually does, because each element of the domain, the 1 and the 2, still correspond to only one element of the range. Meaning, the 1 only has one thing paired with it. The 2 only has one thing paired with it. There's no other 2 out here, you know, with like a 5 with it. Okay, the only time 2 shows up, it's paired with 6. It doesn't repeat and then is paired with something else. So because of that, this thing is a function. Okay, 3 shows up, 4 shows up, they're only paired with different things. So 6 is repeated as an element of the range, but it is not, it's not a first element, a domain member paired with two different things. So this is a function. Alright, now B, on the other hand, we see we have a repeated member of the domain. So this 6 shows up more than once. Okay, so if you look again, each element in the domain, so 6, corresponds to exactly one element in the range. 6 corresponds to 2 different elements in the range. So this does not fit the definition of a function. Alright, both are relations because they're both just a set of ordered pairs. They're both just a set of points. But only one fits the definition of a function. Okay, this has a repeated x value or repeated domain element, and there's more than one range element it's paired with. Okay, visually we can see a domain and range this way. If you have an arrow going out of each member of the domain, and a single arrow. So each, and remember the domain here, this is the same set we were just dealing with here, 1, 2, 3, 4. All right, 1, 2, 3, 4. But then 6, 8, 9, 6, 8, 9. This time, the 1 and the 2, even though they both point to 6, they each have just a single arrow coming out of them. But down here, the second version, this is the same as B in the previous slide. The 6 has 2 arrows coming out from it. So this is when we have something that's not a function. Alright, and then this is okay. This is a function. So just make sure you understand a domain element having 2 things paired with it is not a function. So it's okay if 2 different elements of the domain pair up with the same element in the range. It's not okay when one element from the domain pairs up with 2 and still be a function. Alright, functions as equations. When we say y is a function of x, or y as a function of x, we mean that when x becomes a new value, when x takes on some new value, it is only paired with one y. So as x changes, y can't be 2 different things for any one x. So the way you're supposed to do this is to solve the equation for y. So if I solve this equation for y, I'm going to subtract x squared from both sides. And I end up with y equals 4 minus x squared. And you ask yourself, if I pick a number for x, is it possible to get more than one y? If it is, then that's not a function. But if I pick something for x, like if x is 1, 1 squared is 1, 4 minus 1 is 3, I only get one y. If x is 12, 12 squared is 144. 4 minus 144 is negative 140. I only get one y. There is no x that I can plug in here. No value for x that I can plug in. Square that number, subtract it from 4, and get more than one y. I'm always going to get just one number here. So this is a function. So we would say y is a function of x. Alright, now if we switch to b, if we solve this for y, if I subtract x squared, just like I did before, okay, it's almost the same equation other than the fact that we have a square here versus not having a square here. Now at this step, when I take the square root of both sides to get the y isolated, I have to remember this other thing could have been positive or it could have been negative. And now you see the problem. If x is 0, I get y equals plus or minus the square root of 4, because 4 minus 0 squared would be still 4. So let me just show you over here. Y equals plus or minus 4 minus 0 squared would be y equals plus or minus 0 squared is 0, so 4 minus 0 is still 4. Well, the square root of 4 is 2. So y could be positive 2, but it could also be negative 2. So that means when x is 0, I get y could be 2, but I get y could also be negative 2. So I get 2 different y values for a given x value. So that means that this is not a function. So y is not a function of x here. I should write it that way. Y is not a function of x. Okay, x over here, x is squared, x is squared. Here, y is to the first, y is to the second here when it's not a function. That's no coincidence. Okay, anytime you have a y raised to an even power, y will not be a function of x. Okay, that's kind of a little shortcut way. If the y is raised to an even power, then that is not a function of x. But this is the way that they're wanting you to come up with it. Now again, go back to the original equation. You can kind of do it from here as well. If I pick a value for x, like I pick 0 for x, I get down to y squared equals 4, which is kind of the same thing that we got to here. We just are a step ahead of ourselves. So if I squared y and got 4, then again y could have been positive 2, but it also could have been negative 2. Because if I square negative 2, I also get positive 4. If I square positive 2, I get positive 4. So I get two different values for y for a given x. I plugged in 0 for x here, ended up with two things y could have been. So again, I could do it that way, but it's all because of this even power right here on y. Because that's even, and we get a positive number here, we could have had two different things that are producing that positive number. Okay, so that's what we got to remember for functions as equations. If you're being asked, is y a function of x, just look at the power on y and see if it's an even power. If it is, it's not a function. If it's an odd power, then it is. Okay, now just notation stuff. X, we typically call it the independent variable. The independent variable can take on any value from the domain, okay, as long as it's a valid input. And we'll get into what is a valid and invalid input later. And then the variable y is called the dependent variable because it depends on what x is. We get the value of y by doing something to x. We pick a number for x, do some stuff, solve for y, and so y's value depends on what x we picked. And that's the reason why we call it what we call it. Alright, function notation, f of x is the way we read this, f parentheses x. We read it f of x, it's not multiplication, that's the big thing you got to get down. So a lot of people see that parentheses and they think, 3 parentheses 2 equals 6, that's multiplication. That's not what this is. It doesn't mean f times x. What it means is, if I have a notation like this, f of x equals 2x minus 1, it means f is the name of the function, and the function f takes an input x. X is the name of the input. And what the right hand side is how you get the output, which all of it, the f of x altogether, means output, which is just another way to say y. Alright, so f of x is the same thing as y. So y, f of x are the same thing. Y equals f of x. They're identical. But this is just like how to get y from x. And you think of this as like a set of instructions. Alright, what do I do to get y from x? The first thing I do is, and it's just order of operations, the first thing I do is a multiplication, subtraction, so I'll multiply first. So you double the input. Alright, and then after I've doubled the input, what do? I subtract 1. And that's the steps to get the output from this given input. Okay, now the y-coordinate is obtained by doing whatever the function says to do. That's again what this says. So if I'm given an ordered pair that's incomplete, like let's say for instance -3 comma blank is an ordered pair. That means the x-coordinate's -3, and to get the y-coordinate you got to do this to it. So we would write f of -3. Okay, remember this is like in an ordered pair, x is first, y is second. So the first thing in the ordered pair is -3. That's the input, because that's going right here in where the parentheses was. So we replace the x in the parentheses with -3. So that means -3 is going into the function. Okay, it's like some kind of a pouch or something, like on a kangaroo or something. So we put -3 inside the function f. What does it do? It doubles the input. So it doubles negative 3. And then after that, what does it do? It subtracts 1. So 2 times negative 3 is negative 6 minus 1. Negative 6 minus 1 is negative 7. So when negative 3 is the input, negative 7 is the output. Okay, and we could also say f of negative 3 is negative 7. Okay, it's just a way, this function notation is just a way to say what is the y value when this is the x value. Okay, but we use it also to state the way we get y for each x. Okay, it's initially given to us with just this blank notation. So none of this stuff is essentially there at the beginning. You're just given f of x equals 2x minus 1, and you have to know that means to get y, do this. Okay, and it doesn't matter what the input is, this is still what we do. Alright, so let's go a little bit further with it. What do we mean by no matter what I put in here, that we always do the same thing? Well, I mean literally I can put anything in here. So I can put in 0. F of 0 means double the input. So the input now is 0. So double 0, then subtract 1. Well, if I double 0, I get 0. And then subtracting 1, I get negative 1. Okay? If I put in another letter, like let's say I put in A instead of X. Well, what does it do? It takes the input, it doubles it. The input now is A, so I double A, and I subtract 1. Okay, it's just this time I can't simplify it anymore. It's just 2A minus 1. But I have to be able to do this to any input. So I could be able to take some other expression, like for instance, x squared minus 10. Now this expression, this algebraic expression is an input because it's in the parentheses beside the f. So this is what we're putting into the function f. What does this function f do to any input? It doubles the input. So it's going to take that input of x squared minus 10 and it's going to double it. And then what does it do after that? It subtracts 1. So yeah, you can think of it as we're replacing x in the original expression by what's in this parentheses, because technically that is what we're doing. But the reality is it's a list. A function notation is just a list of instructions to do to an input, and that input is given in the parentheses. Okay, this has got a parentheses, so I need to distribute 2 through. So that's going to be a 2x squared minus 20, and then minus 1 more. Combining my like terms, I get 2x squared minus 21. Okay, so again, we need to be able to put in anything inside of a function and understand what it's telling us to do. So remember, function notation, think of it as just a list of instructions, and the order of operations will determine that list. Alright, this particular function f takes an input, it squares the input, it triples the input, it adds those together, and then it adds 5. So what's it going to do to 2? It's going to square 2, it's going to triple 2, it's going to add those two things together, and then it's going to add 5. So again, I just basically replaced x with that number, okay, whatever number's in this parentheses. And then you just simplify. 2 squared is 4, 3 times 2 is 6, and then add the 5, 4 and 6 is 10, and 5 more is 15. Now what if it's x plus 3 that goes in? Well, whatever the input is, I square that input, so x plus 3 squared. I multiply the input by 3, and then I add 5. X plus 3 squared, remember this is something you need to FOIL out. Don't just square the x and square the 3. FOIL it out. Alright, distribute the 3 through here. I'll get a 3x plus 9. Alright, and then when I FOIL this out, I get x times x is x squared. X times 3 is 3x. 3 times x is another 3x, so that's 6 x's when I combine. And then 3 times 3 is 9. And then I combine my like terms. So 6x and 3x is like, it gives me a 9x. And then 9 and 5 are all like. So that's 18 plus 5 more is 23. Alright, and the last one has us put in negative x into this thing. So if I take the original function and I plug in negative x, that means the opposite of the original input. So x squared plus 3x plus 5, I'm squaring the original input. I'm multiplying the original input by 3, and then I'm adding 5. Okay, now when I square negative x, it literally means negative x times negative x. Positive 3 times negative x is negative 3x plus 5. Right, negative times a negative is a positive, x times x is x squared. So I almost get back to what I originally started with. I started off with a positive x squared plus 3x plus 5, and I end up with positive x squared minus 3x plus 5. So we're not quite back to what we started with. If we were, that would be called an even function. We'll get into that later. And there's another thing called an odd function that we'll look at. But just know if you ever plug in negative x and you get back the same thing you started with, that's a special property that we're going to be interested in later. Okay, so again, you need to be able to plug in anything into these things.